Saxon Algebra 1, Lesson 103. The topic is a topic we've had before. We just keep making it a little bit harder as we go. Well, I mean, not harder, more complicated. Rational expressions. Rational equations, sorry. My bad. Rational equations. Rational is a word that simply means fractions. Equations is a word that tells us basically that we're going to solve for x, right? We're not just rearranging and trying to make it more compact. We're actually solving for a letter. So, okay, let's start with something that's pretty straightforward. And I'll tell you why it's straightforward after I show you what it looks like. Our instructions are to solve. Again, that's a word that tells us we have an equation rather than an expression. Expressions don't have equal signs. Ready? Y over 2 plus 1 over 4 equals y over 6. Okay, they're rational because they're fractions. That's all that means. Equations, yep, there's an equal sign. And we're solving, in this case, technicality, we're solving for y, not x. But still, we're solving for a variable in this equation. Okay, now how do we deal with these denominators? Okay, how do we deal with denominators in any situation? Normally our rule is that we have to make them match, but here's the good news. When we have an equation, okay, not with expressions, but with equations, we can completely eliminate denominators. We're going to blow them up. That, for some reason, is the very graphic expression that always comes into my mouth when I talk about this. We're going to blow up these denominators, and they're not going to exist anymore. How do we do that? First, we find the LCM, the least common multiple, and we do that just like we do all the other times we've ever done it. 2 and 4 and 6. Okay, 2 goes into 4, so we don't have to do anything special with that. 4 and 6, that's going to be 12, right? Okay, so what we're going to do is we multiply each term by the least common multiple, okay? And this is how, I feel like maybe we've done this, I get confused because I teach all these different levels, so I can't remember who's learned what before. So bear with me if you've seen this before. I'm going to explain it like you haven't. So we multiply each term on both sides of the equation, and by terms I mean anything, the different fractions, all right? You'll see that as we go. They're connected usually by pluses or minuses and then the equal sign. But we multiply just the numerators by that LCM. Now, when we go to simplify this, we're going to be able to cancel. 12 and 2 cancel to 6. So this becomes 6y. 12 and 4 cancel to 3. So this is now 1 times 3. I wrote it in the opposite order. Cross those out because we've dealt with them. 12 over 6 is 2. So we now have 6y plus 3 equals 2y. What? Right? Isn't that crazy? So now we don't have denominators anymore. Praise the Lord. Let's just carry on and solve this. I'm going to subtract the 6y, even though I don't like that because it's the bigger y, but this number's on this side, so I'm not going to swim. No, that's too much work. 3 equals negative 4y, and then we divide both sides by negative 4, and we get y equals negative 3/4. And that's the correct answer. And I forgot to finish my list, which I got distracted by. We multiply each term by the LCM, then we cancel to simplify. Okay? And when we simplify, it makes all the denominators go away. This one was nice and easy because we had pretty simple numerators, so it was fairly easy to cancel and then multiply that really quickly. Sometimes that's going to get more complicated, as we shall see, but it's all right. John's going to baby step us into this. So let's try the next one. Here's the major wrinkle in the next one. Solve our instructions again, and this time we have t as our variable. All right, now you see that not only do we have variables in the numerator, we've got variables in the denominator. And whenever you see variables in the denominator, you have to stop and think for a second. Because we never want to blow up the kingdom, right? Or blow up the universe and it would look like the kingdom, only on a far greater scale. We can't let 0 happen in our denominators. So whenever we see a letter in the bottom, we take that denominator and say it can't equal 0. So t cannot equal 0. And 3t cannot equal 0. Okay, 3 cannot equal 0, but that's not a thing. We don't have to worry about that one. This is a perfectly good statement in and of itself. For this one, we always do the algebra to simplify it. And what we see is that if we do the algebra to get that t by itself, it just comes back to the first one that we had, right? Saying t can't be equal to 0 solves both of these problems, right? Because that's the only way we could get a 0 down here was if t was 0, and then it would be 3 times 0. So this statement alone is part of our solution. And we always have to keep it in mind that whenever we have variables in a denominator, we have to make a careful statement over there to make sure that we don't blow up the universe. Okay, so now we're back to our process before. And remember, this is only when the variable is in the denominator. When we have variables in the numerator, that's okay. We can't hurt anybody. All right, so now we have to find the LCM. Least common multiple of these. I wish I had someone to call on, but I'll have to do it for you. It's 3t, right? 3 times t, it works out beautifully. So we're gonna multiply all 3 terms by 3t. And when I see that I have an expression in the top, I put parentheses around that because I'm gonna have to distribute. So I put the parentheses around right in the beginning so I don't forget about that. This one is less drama, this one is less drama. But this expression here needs those parentheses so we don't screw it up. Okay, but we're actually only gonna distribute the 3, right? Because the t's cancel. Here, everything cancels and we don't have anything to multiply by 14. Here, the 3's cancel and then I'll multiply this by t, right? I can cross all that out. Okay, so we're gonna have, I'm gonna write it one more time before I simplify. So this 3 was left. We're going to multiply that by the t minus 2. This one, everything canceled. And this one, the 3 canceled and we just had the t left. We multiply the t by the 1 and get that. Okay? Whew. It always feels so good to get rid of those nasty denominators. Sorry, no offense denominators, but you just make it too complicated looking. We get to this and we go, oh, that is cute and easy. We'll distribute 3t minus 6. I used to always, well, not always, but I can remember at least one test where I forgot to distribute to the second half. Please remember, equals 14 minus t. I'm going to add the t to both sides, swim the t's to the left, and then I'm going to add 6 to swim the plain fish to the right. You're gone, you're gone. 4t equals 20. Oh, that's pretty cute. T equals 5, and we check that against this to make sure that our solution fits within this restraint that we placed on ourselves, and it's a-okay, and that's the right answer. All right. If we got an answer of 0 and we saw, oh wait, according to our restraints, that can't be 0, then our answer would be no solution, null set, empty set. You know how we make those symbols. I'm not sure if we're gonna have one of those in these lessons. It looks like they all have actual solutions. But if you ever came across that where your answer was equal to this, no solution. Okay, carrying on. We have a couple more. This one has 6 examples in all. But that's okay. We can go faster now that we have the hang of it. 103.3, solve. Okay, n over n plus 2 minus 3/5 equals 0. We see a variable in the denominator, so we right away say n plus 2 cannot be equal to 0. Then we do the algebra to simplify that. N cannot be equal to minus 2. That's the condition we're putting on this. And we see that makes perfect sense, because if n were minus 2, then that would be 0. The 5 is fine. We don't have to worry about that. All right. Good. Now we have our process of blowing up denominators in front of us. Least common multiple, there's no way we can make those match, so we just have to multiply them together. 5 times the quantity n plus 2. This is the best way to write that. So now we multiply. I write it up like this. That is the best way I have found for me, so that I can see what I'm doing. But I don't turn it into a big mush pile of numbers up there by angle parking them. It works a little better. That's how I always think of it. It's like an angle parking thing. You know what I'm talking about, right? When you park, sometimes the parking places are straight and sometimes they're angled. That's what I think of. It just makes it neat and easy for me to see what I'm doing. Okay, so now we have multiplied everybody by our LCM. Now we're going to cancel. In the first one, this cancels, that cancels, so it'll be 5n, and now I'm going to cross out the 5 because I've rewritten it there. Here the 5 cancels, and so it's going to be 3 times the quantity n plus 2. This has the parentheses around it. We're good. This one doesn't have a denominator, so nothing cancels, but look, it's times 0, so by. That always used to make me nervous when I was a student, because it just seemed like you can't just wipe everything out like that. But here's the news, you can. So let's go back and see what we've got. This one we fixed, it's just 5n minus, and then I'm going to distribute it in a second step. Okay, so 3 times the quantity, because the 5's canceled, so that's what's left. And then that's all gone. Okay, and again, that seems wrong, but don't worry. Now we're going to distribute this bit. 5n minus 3n minus 6 equals 0. I'm going to, oh wait, see what I did? I was thinking how the next step is going to be adding the 6, and so I wrote a 6 instead of a 0. That's how mistakes happen, teacher. Okay, let's add 6 to both sides, and then we'll combine those like terms, and we'll get 2n by equals 6, n equals 3. We compare that to our restraint, and we see that we're fine. N equals 3, that's the right answer. Yay, this is correct too. All right, did I smiley face these? Yes. Whew. Can't live with myself if I forget those smiley faces. Oh, hi, Luna. Did you hear him? He cried. Okay, my cat wants to come in. I have to go let him in, you guys, and I don't want to pause the video because then I'll have to start over. Wait right there. Okay, go around, cat. Okay, I'm back. Thank you for waiting. Luna thanks you for waiting. 103.4. Ready? Here comes another one. You would be at the board working by now. I would not be doing these problems anymore. You guys make me do so much more work. This whole stay-at-home thing is working me to the bone. Okay, 3n minus 2 over n plus 4. Okay, beautiful. Here we have 0 on this side again. That means whatever we multiply is going to evaporate. We have to just embrace the fact that that's okay. We set our conditions. 3n cannot equal 0. So we find that n cannot equal 0. And n plus 4 cannot equal 0. N cannot equal minus 4. So here are two conditions. Obviously, you guys, you can do these in your head pretty easily. So feel free to skip the writing out of the steps when you feel ready. And you can shortcut this as n cannot equal 0, comma, minus 4. That's another way to write that. That is a little bit shorter. Okay, so back to blowing up our denominators. Least common multiple. There's no way to make that cute. It's just 3n times the quantity, n plus 4. Remember, this is why I like to call it a least common multiple instead of a least common denominator, because it reminds me, the very word reminds me that this is all about multiplying. There's no adding or subtracting we can do to create a least common multiple. It's only multiplying. So that is kind of a reminder to me. All right, so 3n times n plus 4 quantity got my angle parking going on up there. Then I can cancel, this is left. Cancel, this is left. And that all goes away because when you multiply, it doesn't go away because we cancel it. It goes away because we're multiplying by 0. All right, 2 times the quantity n plus 4 minus 2 times 3n equals 0. Sorry, I'm getting distracted. And now 2n plus 8 minus 6n equals 0. I'm going to subtract the 8 and combine the like terms. Goodbye. Minus 4n equals minus 8. Oh, John. N equals 2. I combine it. I look over here at my restraints and I see I'm good. So this is a perfectly fine answer. Yay. 2 more. Are you having fun? I kind of am. These problems look really hard and messy when you first glance at them and realize there's all these steps, but then you get in the habit of just crashing them and they're fine. Example 103.5. All right, 4 over x minus 7 over x minus 2. It does not help me to say that out loud. Okay, x cannot equal 0, and I can look at this one and x would be 2 would be the problem. I don't have to do algebra with my pen to figure out that x equals 2 would be the problem here. So there are my 2 restraints. Now I solve my least common multiple. There's no way I can turn an x into an x minus 2, so all I can do is multiply. Okay, the x's cancel. I'm left with that. The binomial cancels and I'm left with that. And then that goes away, not because it cancels, but because we're multiplying by 0. Ready? Let's see what we have left. You could distribute it this step. Like I said, I'm just going a little bit slower so that you can see exactly what I'm doing. But if you wanted to distribute and go 4x minus 8, that's fine. I'm doing it now. And same as before, I add I'm thinking of the 7 and the 4 and the 3 that I'm gonna have, but that's not the right time. And I'll combine those like terms. This will give me minus 3x equals positive 8. and then I'll divide by -3, and I'll get x equals, no, I'm dividing by -3, -8/3. Remember that we can have the minus sign in front of the denominator, in front of the numerator, or just kind of hanging in the middle in front of the whole thing. Oh, this looks like I wrote it in front of the top. Normally, we like our answer to look like that. Mine was, I didn't mean to put it by the 8, I just was a little haphazard in the way I slapped that puppy down. Okay, so -8/3 is correct, and we see with our restraints, we're fine. One more, and then you'll be turned loose to do some of these on your own. 4/p. And once again, we have it equal to 0 on the other side. It's fine, don't let it freak you out. Okay, so our restraints, p cannot be equal to 0, and p cannot be equal to 4. +4 would create a 0 in that situation. All right, so there are our restraints. And always check these too in your answer. John shows them as part of the solution. So make sure that you check and have the proper restraints. This is right. Okay, LCM. P times the quantity, p minus 4. These cancel. This is left. This cancel. That's left. That's gone away because we're multiplying by 0. This time I'll distribute it in my head. 4p minus 16 minus 3p equals 0. Add the 16. Combine the like terms. 4p minus 3p is 1p. P equals 16. That's our answer right there. It's not a problem. Yay, the lesson's over. I mean, I know we're all having a really good time with this lesson, so I'm not cheering that the lesson is over, but I'm cheering our amazing accomplishment because we satisfied yet another lesson. Here are your steps once again. We're gonna, because we're doing fractions in equations, we can completely eliminate the denominators. We can't do it for expressions, but with equations, see, look at that, exquaporations. This says equations. When we have equations, we can completely eliminate the denominators. There are the steps if you need to remember them. And we have to set up the restraints anytime we have variables in the denominators. That's what drives our need to do that. Lesson 103, you were fun, but you're done now. Goodbye.